Greetings, one and all. Today we will be going through a very interesting project which aims to build an oxygen concentrator using PSA technique. And my team members are me, myself, Ashish Adhikari, Suyesh Kushti, Gaurav Patil, and Usman Sayyed. So here are the contents for our project: introduction, literature review, oxygen cylinder versus oxygen concentrator, working of oxygen concentrator, components, methodology, cost estimation, conclusion, and references for the same. So for the introduction, as these 2 years has taught us a lots of life lessons, including taking care of self and our close ones. Many has also lost their close ones as COVID-19 pandemic has affected many of us. Thereby, ones who were suffering has sent a strong message to the society that need of the oxygen supply is increasing day by day to save one's life, and due to which we fellow engineers heard the voice of poor sufferers. Hence, the oxygen concentrator serves the need. So, also, not only this, many families during the pandemic needed oxygen supplies at a large amount in less cost price also, but oxygen cylinders then were costly, also were not available in large amount. Hence, oxygen concentrator eliminates the need of oxygen cylinder, which are costlier than oxygen concentrators. So next slide will be reviewed by my team member Usman Said. Over to you, Usman.
Thank you, Ashish. So, coming on to the topic of literature review. So, what is an oxygen concentrator? An oxygen concentrator is a medical device that gives you extra oxygen. Your doctor may prescribe one for you if you have a health condition that causes your oxygen level to drop too low. So, it can help some of the people who have trouble in breathing conditions like asthma, lung cancer, COPD, the flu, and the main reason COVID-19. So you need to get your doctor okay before you buy or use any oxygen concentrator. Using one without their guidance or prescription can be dangerous. If your doctor thinks a concentrator might be right for you, they'll let you know how much oxygen to take and how long to use this device. And also, a project aim is to provide the economical oxygen concentrator by using simply PSA technique. Our motive is to provide an budget-friendly oxygen concentrator which can be afforded for the middle class family and also for the non-ICU or critical patient which require less concentrated oxygen. Next slide. So why we have opted for the oxygen concentrator, not for the oxygen cylinder? So here we can see the comparison, like cost is comparatively high in oxygen cylinder, and yes, the concentrator cost is also high, but it is a one-time investment. Oxygen cylinder is heavy and large in size. Oxygen concentrator is portable, comparatively light in weight. The oxygen cylinder does not provide 24 by 7 oxygen that it can run out of oxygen. It can provide oxygen concentrator can provide 24 by 7 oxygen as long as electricity is available. Oxygen cylinder transportation cost is costly and no requirement for transportation cost once it's purchased. So the next slide will be introduced by Ashish. Over to you, Ashish.
Thank you, Usman. So, as we have discussed early, as Usman has stated the difference between oxygen concentrator and oxygen cylinder. So, let's move on to the working of oxygen concentrator. So, as we all know, air is adequately available in the atmosphere. Hence, we are taking air from the atmosphere, which consists of 78% of nitrogen and 21% of oxygen and few percent of other gases. Our oxygen concentrator will be using PSA technology, which is stated as pressure swing adsorption. So, the air from the atmosphere goes into the compressor through a filter to separate out the dust particles, and compressor throws out a highly compressed hot air, which is then fed to an heat exchanger. So the heat exchanger is mainly used for cooling purpose of the hot air, compressed air, which consists of a round helical copper tube with a Peltier module for cooling the compressed air efficiently. After that, cooled air is fed to the PSA column in which main operation of oxygen concentrator is going to take place. Via a two-way solenoid valve, we fed the air coming out from the compressor to the columns. So the columns are filled with zeolite molecular sieves which are used to separate out nitrogen and oxygen and filter out the oxygen. Then the oxygen under pressure is released through a two-way solenoid valve to humidifier pressure regulator and to the what we can say to the conservator or directly to the medical use. Next slide please. So here is a basic gif of how an oxygen concentrator actually work in a system. Like the air is coming from the one side and it is the PSA technique is carried on in the middle, the heat exchanging in the second phase, and then directly to the medical uses. So the next slide or next review will be done by my teammate Suyash Koshti. Over to you, Suyash.
Thank you, Ashish. So till now we have seen working of oxygen concentrator, what is oxygen cylinder and what is oxygen concentrator, and the objective of our project. So now let's have a look at the components which are required to execute this project. We need a compressor. A compressor is a device which converts power into potential energy, which is stored in a pressurized air. An air compressor forces more and more air into storage tank, increasing the pressure. So we need a compressor so that we get a pressurized air at the output side. In this application, we need a compressor which can create a pressure of 3 to 4 bar, and this compressor should be an oilless compressor because we don't want oil contamination in this application. So next is a Peltier module which is used to cool down the temperature of the air below ambient temperature. Peltier module consists of two ceramic plates which are separated by the semiconductor pellets. A voltage is applied across to a junction to create an electric current. When the current flows through the junction of two conductors, uh, the heat is removed at the one junction, and uh, cooling occurs at another junction. Heat is deposited at like I said, heat is deposited at the other junction. Uh, the next is a moisture trap with a pressure regulator. Uh, a moisture trap is used to remove the moisture from the air, and pressure regulator is used to get a constant pressure to output at the output of the pressure regulator. Now, solenoid valves which we are using are two-way solenoid valve and three-way solenoid valve. Valves are normally open. Both valves are normally open. Next we are using is a timer relay. Solenoids are operated through the timer relay. Time delay are given to these relays, and according to which output is generated. And the next is rotometer and humidifier. Rotometer is used to check the flow of oxygen uh, next to our columns, uh, and the humidifier is used to humidify the dry oxygen. That's all. Over to you, Gaurav.
Thank you, Shish. Now moving on to the methodology, meaning how we implemented this project in practical terms. After deciding the topic of our project, we started listing down the components. That means we started listing down the requirements for our project. After the requirement, we started to understand the design of our project and also started looking out for the for how the components will get assembled. In this project, each and every component is crucial, and each and every stage of this project serves a purpose. So missing out any components in the requirement list won't be that feasible. Also, while creating the component list, we were trying to reduce the cost or cost cutting in some components, which can be used as a replacement for that. This will overall reduce the cost of our project. As our main aim of the project was to provide budget or pocket friendly oxygen concentrator, we were in search of the technique which will be easy in search of this technique which will be easy to execute as well as cheaper than the conventional technique that is used in the market currently. Generally, in the market, oxygen concentrator are made of ATF technique, which is nothing but advanced technology fractionators. This is a technology which is compact and provide the good level of concentrated oxygen as an output. But ATF is a patented and registered technology, and it requires huge loyalty fees, and hence using this technique is costly. An alternative technique for ATF is a simple PSA technique, which is nothing but pressure swing absorption. PSA is basically based on the phenomena that under high pressure gases tend to be trapped into solid surfaces like zeolite. Zeolite is the best example that stores the nitrogen and passes the oxygen. After deciding the technique and the required components, we started deciding budget of our project, and after that we started finding the right supplies or shops from where we can get these components by doing market surveys. After market surveys and procurement of the required components, we started implementing and assembling the component. We started implementing and assembling the components according to the process that we imagine or design. Now moving on to the next slide, which is the bill of material. Uh, as you can see, these are the number of components that we are using as well as their cost in rupees. The prices may vary depending on your location to location. Now moving on to the conclusion of this presentation. Uh, Actually, we try to develop a oxygen concentrator which is budget friendly, and which is actually really beneficial for the society. This oxygen concentrator will be actually beneficial for the patients who require oxygen, but in less concentrated form, such as non-ICU patients or non-critical patients. Now, these are our like conclusion that we will say that the oxygen concentrator actually provides us 24/7 oxygen, so it is a reliable source of oxygen supply. Now, these are our references that we refer to present this PPT. Thank you.
Hello everyone, as we explained in the presentation, here is the actual setup of our project. Initially we have given the supply, the air supply through the compressor, which is giving us the supply output of 3 to 4 bar pressure, and through that we are getting the air supply to the helical coil, which act as a heat exchanger, and through that air is passed to the Peltier module, which is connected with the water block. Here you can see that, and through that water block the air is passing, and after that the regulator, the pressure regulator as well as the moisture trap is present over here, and through that moisture trap we are supplying the air supply is supplied to the solenoid valve, and the solenoid valve then after splits the air into these two columns, two columns, and these two columns are filled with the zeolite material, which is of 13x sizes, and both of them are filled with the zeolite, and we have mounted them on the tripod as well as the stand. At the end of the both of the columns we get the air supply, oxygen air supply, which we can regulate through this regulator. Here you can see the regulator, and after that you can also store that in the air oxygen tank or maybe container where you want to store the oxygen, and then use for the other purposes. After that we have done a synchronization cycle between both of them. At the initial stage, the inlet air is supplied to both of them for 1 minute, and after that this controller, which is exhaust solenoid valve, this solenoid valve starts, and for 30 seconds the exhaust happen. This is because the zeolite traps the nitrogen gases in it, and after few seconds the nitrogen gas which is absorbed by the zeolite material is then taken out through the exhaust solenoid valve. And this is how our actual setup looks like. And we are controlling all the electronic system using the delay trigger relay, which is synchronized between each other. And at the inlet side we have turn on the solenoid valve for 1 minute, and at the outside side, that is exhaust side, we have turned on the solenoid valve for 30 seconds. So this is how our actual setup looks like. You can see the whole setup. Hello guys, so here is the actual working of the system. At the initial stage, the air is supplied through the compressor to the helical coil, and after that the air is supplied to the Peltier module. This both of the system, the helical coil and the Peltier module, act as the heat exchanger, and the cooling of the air is done in both of them. After that, the air is passed to the air pressure regulator as well as the moisture trap, and the air is then supplied to the columns. Now let us actually see how actually the system works by turning it on. Now you can see that at the initial stage the cycle of 20 seconds is present, and the air is getting supplied to the column, and we can see that the output is coming as the air is getting vented. And after that, for 20 seconds the air is getting vent, and we can see that there is no air supply or no oxygen at the output side. And here you can see that the switching will happen after 1 second. Here you can see that again the air is getting supplied at the output. So there is synchronization between both of the solenoid valve, and we have kept the cycle of 20 seconds. The air is getting vent for 20 seconds, and again the air is getting filled in the columns for 20 seconds. So it is the actual demonstration or working of our project. Thank you.